Hello there. We're going to have a quick look at identities. So I'm going to give you a couple and we're going to try them. So for example, 1 over x plus 2 times x plus 3 is equal to c over x plus 2 plus d over x minus 3. And we need to find c and d. So in order to find c and d, we need to make the identities look exactly the same. We're told that these are the same, but if they're the same, let's make them look the same. Can't make this look any more the same, so I'm just going to leave this side and do nothing with it. This side, however, I can. So let's say the common denominator would be the two things product. So these two expressions product would be, so look straight away, they look the same. And then in order to generate the top line, I'm just going to cross multiply. So c times x minus 3 plus d times x plus 2. So now they look a little bit different, okay? Or sorry, a little bit more the same. So what we can do then, once we have that kind of done, then you're nearly 90% of the way there from doing it, okay? So the bottom line I can just ignore because I know they're equivalent to each other. Look, they're identical to each other. Sorry, I don't know why there's I don't know, 2. Sorry. So I can leave the bottom line, just look at the top line. So what we're going to do is we're going to try and see what would happen if one of these was 0. Okay, so let's assume for the first case that x is equal to 3. So if x is equal to 3, what would happen to this? Okay, I still have 1 equal to c times 3 minus 3 plus d times 3 plus 2. So that'll be 1 equal to c times 0 is 0 and d times 5 is 5d. And that would give me d divided across by 5 is equal to 1/5. So there'd be one possible answer. Okay, now let's do it the other way. Let's see what happened if I made that 0. So that's x equal to minus 2. And let's see solve. So again, 1 would be the same. So it's c times minus 2 minus 3 plus d times minus 2 plus 2. So again, that becomes 0. So you have 1 is equal to minus 5d. D is equal to negative 1/5. So that's, sorry. C. Not with it today. So that's how you would solve those fractional identity type of questions. Now, let's go on to the more fun type of identity questions. Okay? And that would be a case like this. Let me find a nice one here. X squared plus p is a factor of, let's see, x cubed minus 3x squared plus px minus 15. Find p. Okay, so again, like anything else, let's assume we knew what we were doing. If that's a factor, and then if I divide that in, I should be left with no remainder. So that's what I'm going to try and do. X squared plus p, I'm going to divide that in to x cubed minus 3x squared plus px minus 15. Okay, so that's going to be my kind of trick. I'm going to divide it in and see what happens. X squared into x cubed goes x. Let's reverse the process. Multiply both these things by x. Okay, now, as you can see, when you multiply it, something weird happens. It doesn't generate an x squared. Okay, so it doesn't generate an x squared. So that's something you have to kind of account for. So when I change the signs on this bottom line, okay, what's happening is x cubed minus x cubed is 0. And we still have the minus 3x squared. We still have the minus px. We still have a plus px. And we still have a minus 15. Okay? So, x squared into minus 3x squared goes minus 3x. Sorry, goes minus 3 times. Multiply it back out. Minus 3x squared minus 3p. Okay, so same thing again. Change the signs. Plus, plus, cancel. These two have cancelled, so I don't have to write anything down for them. So I have a plus 3p and a minus 15. Okay, so that is all that's left over. That is my remainder. But the remainder, if that is a factor of that, the remainder must be equal to 0. So this must be equal to 0. 3p minus 15 must be equal to 0. That would mean that 3p would be equal to add 15 to both sides, and that would mean divide both sides by 3. P is 5, and that would be your answer. So that's a simpler identity type of one. Now, I'll give you a more complicated identity, like a really complicated one. Let's say x squared plus ax plus b is a factor of x cubed minus k. Show a cubed is equal to k and b cubed is equal to k squared. So this is like a proper full-on identity type of question. So how will we do this type of one? Same method applies. Set it up so you're dividing it in as if you knew what you were doing. I'm going to divide this into this with the proviso that there is no remainder. Now, if you look at this very carefully, that's a constant. There's no a variable attached to it. So I'm going to add in some dummy ones just to fill the gaps so this doesn't look weird when I try and multiply it out. So x into x cubed goes x times, x squared into x cubed goes x times. Reverse the process. X cubed plus ax squared plus bx. Change the signs. Minus, minus, minus. That's gone. We have minus ax squared minus bx and bring down the minus k. And we're going to go again. X squared into minus ax squared goes minus a times. Reverse the process. Minus ax squared minus a squared x and minus ab. Change the signs. Plus, plus, plus. So that's going to leave me with a squared x minus bx and ab minus k. And now you're thinking to yourself, well, that just hasn't got me anywhere near the answer, but it has, because this must be 0. So I'm going to section this off into the x component and the constant component. So watch, a squared x minus bx has to be 0 if there's no remainder. And at the same time, ab minus k has to be 0 if there's no remainder. So let's see what I can do with these two to see can I get back up to either of these. I can divide both sides of this by x. So a squared minus b is equal to 0. A squared is equal to b. Okay? And this side, I can just make ab, add k to both sides, is equal to k. Okay, so straight away I can see here, b is a squared. So if that's the case, I can put a squared there. So that's a times a squared is equal to k. That means a cubed is equal to k. And I think that solved one of my problems. Okay, so that has solved one of my problems. And let's see, can I solve this other problem? This other problem says that k squared is equal to b cubed. Well, I have an expression for k. So let's have a look at that then. So if that's the case, I could multiply both these sides. I could square both these sides. So I could go ab squared is equal to k squared. So I have my k squared, I just need a b cubed. So I know that a squared is b. So if I square this out, that's a squared b squared is equal to k squared. But a squared is b, so that's just b times b squared is equal to k squared. And of course, b times b squared, that's b cubed, is equal to k squared. So there's your second one done.